Aeroblaze, bridging the energy gap. Rural electrification in the Philippines remains a significant challenge, with many communities facing limited or unreliable access to electricity. Geographical constraints, such as mountainous terrain and dispersed settlements, pose significant hurdles for grid extension. Moreover, the high costs associated with constructing and maintaining power lines in remote areas often make grid connections economically unviable. This results in many rural households relying on expensive and polluting alternatives like diesel generators or kerosene lamps, which can be both costly and detrimental to health and the environment. The lack of reliable electricity access hinders economic development, limits educational opportunities, and impacts the overall quality of life for rural communities. Typhoons are a frequent and significant threat to rural communities in the Philippines, often resulting in widespread power outages. Strong winds, heavy rainfall, and flooding can damage power lines, topple transmission towers, and inundate substations, disrupting electricity supply for extended periods. These outages exacerbate the challenges faced by rural communities, impacting essential services such as healthcare, communication, and food preservation. Moreover, prolonged power disruptions can hinder recovery efforts and exacerbate the economic and social impacts of typhoons on vulnerable populations. In many rural areas like Barangay Wawa in Mindoro, getting enough electricity is a real struggle. The power lines aren't very good, so the lights go out a lot, especially when there's a storm or other bad weather. This means many families have to use generators to have electricity at home. But generators are noisy, expensive to run, and still don't solve the problem of high electricity bills. Even when the power's off a lot, the bills are still really high. It's not fair that people have to pay so much for electricity that isn't reliable. They really need better power lines and a better system so they don't have to depend on expensive generators and pay so much money for electricity that often isn't there. This would make a big difference in their lives and help them save money. Aeroblaze, a proposed wind-solar hybrid system, aims to address the critical issue of energy resilience in rural areas like Barangay Wawa, Abra de Ilog, where power outages are frequent. By integrating renewable energy sources like wind and solar power, Aeroblaze seeks to bridge the energy gap and provide a reliable and sustainable alternative energy supply. This research endeavors to design and evaluate the feasibility of this system, considering factors such as technical feasibility, environmental impact, and community acceptance. By bridging the energy gap, Aeroblaze aims to enhance the quality of life for rural communities, improve economic opportunities, and contribute to a more sustainable and resilient energy future. This study addresses SDG 7, Affordable and Clean Energy, which seeks ensure access to affordable, reliable, sustainable, and modern energy for all. This research promotes renewable energy solutions, such as solar and wind power, which reduce greenhouse gas emissions and fight climate change. Improved energy access and reliable power for underserved communities like Barangay Wawa reduce energy inequality and promote inclusivity. Optimizing energy use, reducing fossil fuel use, and minimizing energy waste improves energy efficiency in the proposed design. The hybrid system also strengthens energy infrastructure, ensuring reliability during natural or technical disruptions. This study aims to demonstrate the potential of wind-solar solutions to bridge energy gaps and contribute to global efforts to create a cleaner, more equitable energy future in rural areas. A solar panel tilted at a 15-degree angle south will receive optimal sunlight during peak hours. This tilt angle is chosen to maximize solar energy capture throughout the year, considering the country's tropical climate and the sun's path across the sky. During these 4.5 hours of peak sunlight, the solar panel will be positioned to intercept the sun's rays at an angle that minimizes reflection and maximizes the amount of solar energy absorbed. This optimal tilt angle ensures efficient solar energy conversion, leading to higher energy output and improved system performance in the coastal environment. The average wind speed in Barangay Wawa, Abra de Ilog, Oriental Mindoro, by 2023 ranged from 6 kilometers per hour. And as for our wind-solar hybrid system, with more than 40 years in the wind industry, Vestas has more experience than anyone else in making wind work. Vestas has installed more than 185 gigawatts of wind power capacity, including more than 10 gigawatts offshore. This extensive experience positions Vestas as a leading authority in wind energy technology and project implementation. The EcoFlow Delta II portable power station is a compact, durable, and sustainable energy solution ideal for outdoor adventures and emergency backups. It features a 1,024 watt-hour lithium iron phosphate battery with over 3,000 cycles, maintaining 80% capacity for years. The Intelligent Battery Management System, BMS, ensures safety by monitoring voltage, current, and temperature. The Delta II supports multiple charging options, including solar panels with an MPPT controller, ultra-fast AC wall charging, 80% in 50 minutes. Additionally, the Delta II can be integrated into a wind and solar hybrid system for continuous, renewable charging, such as the Aeroblaze. While it does not include a built-in hybrid controller, an external hybrid charge controller is used to combine inputs from both a wind turbine and solar panels. The hybrid controller regulates the power output from both sources, ensuring compatibility with the Delta II's input specifications, 11 to 60 volts up to 500 watts. Once regulated, the combined power can be connected to the Delta II's DC input for efficient charging. Versatile and eco-friendly, the Delta II meets diverse power needs reliably. To connect an EcoFlow Delta II to your home from a hybrid wind-solar system, the wind turbine and solar panels will each connect to a charge controller. This controller regulates power from both sources and sends it to the Delta II's DC input. The Delta II's built-in inverter then converts the stored DC power into AC power, which is connected to your home's electrical panel. This setup requires careful system sizing, proper grounding and wiring, and may necessitate professional installation for optimal performance and safety. Elevator for maintenance is traveling down together with the energy. Wind turbine maintenance is significantly improved by incorporating an internal elevator, especially for complex hybrid systems. Safe and easy access to internal components reduces risks and speeds repairs. Regular cleaning and inspections become more efficient, preventing small issues from escalating. This leads to less downtime, lower costs, and a longer operational lifespan. The enhanced safety also creates a better work environment for technicians. Safety gear. Wear insulated gloves and safety glasses to protect yourself from electrical hazards. Location. Place the battery in a well-ventilated area to prevent overheating. Mounting. Securely mount the battery on the wall or floor. Turn off main power. Turn off the circuit breaker to disconnect the main power supply to avoid electrical hazards. Check the power requirements. Ensure that the power station can handle the load of the devices you plan to connect. Connect its inverter. Use its appropriate cables and connectors to connect the inverter to the EcoFlow Delta II. Plug into inverter. Connect one end of the heavy-duty extension cord to the AC outlet of the EcoFlow Delta II. Connect to house socket. Plug the other end of the extension cord into a wall socket in your house. Turn on devices. Gradually turn on the devices you want to power using the EcoFlow Delta II. Check for overload. Ensure that the power station is not overloaded by checking the power usage. Aeroblaze, bridging the energy gap.